I greet you in the Almighty's name. I'm to online, and I'm teacher Alan by name. I'm here to take you through some questions as well as giving you the expected responses. I'm not here to give you the final responses, but to give you the expected one from which you can build on. Remember, we say we don't cram, but we understand the concepts. So we are going to go through a certain item, and we are specifically going to have a look at chemistry for the start. Before we go on, we said we am to online. We offer online classes for the new curriculum, specifically right now. These services are free of charge. We don't charge you any coin for them. Our contact, if you're not part of our WhatsApp group, our contact is 0703 27 82 31. If you're not part of us, if you're not, and we provide all educational services. We talked of a school management site we called Lipo sites. Actually, Lipo.site, it is a school management site. It manages your finance as a school, manages your administration, it manages scores, it manages everything to do with the school. As per now, we have a reasonable number we can move with, and we are good to go. Here we have a scenario I want us to go through as we build some responses for it. The scenario goes, in order to find out the element present in the ore discovered, the head of the discovery team heated 40 grams of the oxide of the element in the ore. In presence of carbon monoxide, the oxide was reduced and 32 grams of solid M were obtained. So the element was solid M. The ore they discovered was in form of an oxide. So were obtained. However, the head of the discovery team was not able to estimate the formula of the oxide. He has approached you for help. Let me think we see this question. You can zoom in further behind such that they can see the question well. So this is the question. In order to find out the element present, I'm reading it again, in the ore discovered, the head of the discovery team heated 40 grams of the oxide of element in the ore. In presence of carbon monoxide, the oxide was reduced and 32 grams of the solid were obtained. However, he was not able to estimate the formula of the oxide. He has approached you for help, and among the help he's asking you to do is taking you as a chemistry learner. He wants you to help him discover or estimate the simplest formula of the oxide. He has given you the atomic mass of M and that of oxygen. He also wants you to describe any simple investigation you would carry out to find out whether the element is a metal or a non-metal element. He also wants you to write an equation to represent the reaction between the oxide of M with carbon monoxide. And the other task is to mention any other uses of carbon monoxide in daily life. For those who haven't seen this question, who didn't start with us, the scenario goes, in order to find out the element present in the ore discovered, an ore is the impure form of a mineral. Minerals usually are made up of elements, but in impure forms. To clear to you the words that I need. So this is an ore. So what he did, the head of the discovery team heated 40 grams of the oxide. And this is, the ore was an oxide. So we are uploading the question in our WhatsApp group. For those who are not part of the group, please, you may find the question in the group. So part A, they are telling us to estimate the simplest formula of the oxide. Remember, the simplest formula is the same as an empirical formula. These two words are the same. For those who had not covered this topic, to get an empirical formula, we follow certain steps when calculating. We always state the elements that are part of the formula. So the elements, this time in the question, we have two elements. We have element M and O, or the oxygen atom, which makes up the oxide. Secondly, we always give the mass of each of the elements. The mass may be in grams or in percentages for each of the elements. The steps we follow when calculating for the simplest formula. The second step, we always give the relative atomic masses of the elements. For those who didn't cover this topic, the fourth step for this calculation, we always calculate for the number of moles of each of these ones. To get the number of moles, we always get the mass of each of the elements. We divide it by the relative atomic masses. And finally, in the step, we always calculate for the mole ratio. For those who didn't know how to calculate for the simplest formula. So to get the mole ratio, we always simply we divide the ratios of the moles we get here, they are the ones we calculate here, and calculate through by the smallest figure in terms of the mole ratios. The numbers we shall get that are in whole numbers, we don't give them in decimal places. The whole numbers we shall get, we will represent the amount of each element. They are the numbers, let's say A and B. They are the mole ratios we got after calculating. A will become the amount of M in the formula, and B will become the amount of oxide in the formula. So the steps are simply stating the elements, stating the masses, whether in grams or percentages, the mass is given, stating the relative atomic masses for each of the elements, calculating for the number of moles, and we said to calculate for the number of moles, we get the mass, we divide by the relative atomic masses on each of the elements, and then we get the mole ratios. For the mole ratios, don't forget we said we divide it through the moles we obtained here by the smallest value of moles we get. Let me think I'm flowing. So to cut the story short, here they are saying that the head of the discovery team heated 40 grams of the oxide. This means the 40 is for the oxide. And they are also saying that they heated in presence of carbon monoxide, but on heating, the oxide was reduced. Reduction is removal in this case, was reduced to 32 grams. So this means this is the mass of solid M, which is the element. That means in the scenario, we have the mass of the oxide as what? As 40 grams. We also have the mass of M. It is given as 32 grams. But in our calculation, in the steps we gave, we said that we only stated the masses of the elements, not the mass of the entire formula. So the entire formula is of an oxide, but we need the elements in the formula, which are the M and oxygen. So we shall look for the mass of oxygen in the formula, which we shall calculate from getting 40 and subtract 32. What we shall get will be the mass in grams. I think it is an 8. That is the mass of oxygen in the formula. To go on, we shall start the steps. We start by stating the elements. That's what we say. So we state the elements. In this, we have element M. To be decent, we make a decent table. And oxide and oxygen. The second step is stating the mass of each. For M, we have 32 grams, and for oxygen, we have 8, the calculated mass. That was our second step, stating the masses. The third step is stating the relative atomic masses. The relative atomic masses for M, when we go to the question, M was given as 64. And O is 16. So if M is 64, and oxide, that of oxygen is 16. Well, our next step will be calculating for the number of moles. Calculating for the simplest formula or empirical formula. These are the steps we follow when calculating for them. You can try more examples when home there. To get the number of moles, we said we get the mass, which is a 32 here. We divide by the relative atomic mass, which is a 64. And here we shall get 8 divided by 16. Here we shall get, when we use our calculator as well, I think this is half of this, and this one is also half of this. So this means our answers will be 0.5 here, and the answer for this will be, this is half of this, so it will also be 0.5, meaning it is a half. When we go to deep mathematics, by 2, by 4, let's use 4. By 4, this is a 2. By 4, this is a 4. By a 2, this is a 1. By a 2, this is a 2. So this is, the answer is a half, which is the same as 0.5. To get the number of moles, the next step we say, we look for the mole ratios. Remember, the moles we have for this is 0.5, and for the other one is 0.5. So we said to get the mole ratios, we always calculate through by the smallest figure. The smallest figure here, they are all the same. So we shall divide it through by 0.5 by 0.5. So the answer, such that the value here is 1, and the value here will be 1 when we divide. Implying that our simplest formula is M. Remember, we said in chemistry we don't represent 1 in a formula. We don't represent 1. So the simplest formula will be M, capital O, as our simplest formula of the oxide. So with that, we shall have responded to the head of the investigation team. To continue with the part B, they are saying that so if you have the question in the, we say who are not part of the group, where we have uploaded the question, you join us via, you reach us via 0703 278 231. That is our WhatsApp number. When you reach us, we shall add you automatically. So to go on, part B is like, describe a simple investigation you would carry out to find out whether the element is a metal or a non-metal. That is our part B. They want to know whether this element M is a metal or a non-metal. So in your everyday life, how can you know that this is a metal, this is a non-metal? How do you get a conclusion that a metal is this, a non-metal is this? In short form, they want you to carry out an investigation to prove properties of metals. To me, remember an investigation, so we are responding to part B. So we shall have an aim. I'm going to choose any of the properties of a metal. To me, I'm going to take a metal as a good conductor of heat, a perfect conductor of heat. I would say my aim is to find out whether M is a metal or a non-metallic element. So this is my aim. I will not go into the details of the hypothesis. What I made, I will go straight to my requirements. What will I need? I've started the aim. I've not given any hypothesis. I want to give a simple investigation. How to know that this is a metal or a non-metal. So I'm going to take, I'm going to go with one property that metals are perfect conductors of heat. So among my requirements, I will need a piece of solid M. I will need that piece of M. I will need a heat source. I will need a test tube holder. I will need a test tube holder. I'll also need wax or candle wax. I'll need candle wax in this investigation. So I'll give the procedures I will follow when carrying out this investigation. Remember, we said that the procedures will give something in a reported form. We are finding out whether this element is a metal or a non-metal. So what I will start with, I will start by putting a piece of wax is put to one end of solid M. I'm going with the property of heat being a perfect heat conduct. So what I will do, I'll get my piece of wax and place it to one end. One end of what? One end of the solid M. So the next step I will do, I will use my test tube holder to hold this this piece of M and place the other end where the wax is not located to a heat source. And I let it be heated for a given period of time as I watch the changes that occur to the wax. Remember, if it is a good conductor, if M is a good conductor of heat, the heat will be transferred from this end where it is exposed to heat to the other side where wax is. Remember, the wax is very weak at any temperature change. So any increase or any slight increase in temperature will make the wax to melt. So what I will do, I will say, using a test tube holder solid M is held with the other side, with the other end in contact with fire. So we use a test tube holder to hold this piece of M, but with the other end of it in contact with fire. Let me think we are flowing. And I'm clear to everyone. So the next step I will take is to observe. Let me hope we finished this. I'm clearing. The next step I will take is to observe the changes that occur to the wax. And I think within 5 minutes, if an element is a metal, 7 minutes, 5 minutes, or 6 minutes will just be enough for one to see the candle melting. So what I will do, I will leave the experiment stand for some time. So what we do, we shall leave the experiment to stand for any specified amount of time. If an element is a metal, of course, heat transfer will be faster, which will not be the case to non-metallic elements. So we may go on and specify time. We may go on and specify the time. Let's say it's left to stand for 5 minutes. To be specific, it's left to stand for 5 minutes as we note the changes that occur to the wax. So after stating the procedures, the experiment should be with limits in terms of time, what to use and how to use them. So we shall have results. And our results in this case will be in terms of observations, as long as, at the same time, a deduction. We shall give the observation. So the observation will be in terms of if the wax melts after that time. Our deduction will be M will be a metallic The first observation we expect, if this experiment is left to stand for some time, that time, let's say 5 minutes, and we find that the wax has melted after that specified time, it will indicate that this element M is a metal. Being a metal, it will imply that it has conducted heat from this end. You may go on and give a setup. Let's say this is our heat source, and this is our metal load. This is our candle wax. This is our solid M, and this is our heat source. If after 5 minutes this wax melts, it will imply that heat was conducted from this end to the other end. And if the wax remain unchanged in terms of state, it will imply that M is a non-metallic element and does not conduct heat. So you choose a property that you feel you can use to be the key to follow when carrying out an investigation. So the observation is on whether the wax melts or not. Let me think I've been flowing to a speed that is everyone can withstand. I'm here to look at some questions and compliments before we continue. Before we go any further, we said if you're not part of us, simply join us via that number 0703 27 82 31. When you reach us, we shall automatically add you to our WhatsApp group. For the question is already in the group, is already in the WhatsApp group. If you don't have it, please check the WhatsApp group. So Naka Uchfiona is with us, Sachi Gift is with us, Caleb is with us, you're most welcome. Caleb, Nanyonjo Shakira is with us, you're most welcome. Mariam Kagoda is with us, hello. Governor Nicholas is with us, Kasoma Colin is with us. He's Nick with us. And I think those are the ones we have. So we've used that property of heat conduction, ability of metals to conduct heat. It is the one we have used to call out the investigation. It is the property we've decided to respond to. You can use any other property. We know metals have high melting point than non-metals. They conduct electricity. All those are properties of metals. So to go on with the question, as I find the questions and supplements, I think we are done with the other part. Let's have a look at another part which is part B. You can think of any other investigation you can use to verify whether an element is a metal or a non-metal. To me, that's what I based on. So the third task is write an equation to represent the reaction between the oxide of M in the ore with carbon monoxide. That is the task. With an equation between the oxide of M in the ore with carbon monoxide. So we got the formula of the oxide, and the formula was, this is part C, the formula was like this. And from the scenario, they are saying that it is an ore, and ores are usually in solid state. So when heated with the carbon monoxide, and this is a gas, the carbon monoxide, they said the condition is heat. The carbon monoxide reduced the oxide to its metal M, and for it, it is always oxidized to carbon dioxide gas. So it may think we are getting and we are together. So we get the oxide is reduced by the carbon monoxide to metal M, and the carbon monoxide is oxidized to carbon dioxide. I think the equation is already balanced. So long as you include the states and the mentioned condition. We said the plus sign on the reactant side stands for this one reacts with the other one at this condition to give the other one and the other. And this plus on the product side stands for and or with. This states the S, the G, this is a state of matter of this one, and it is in solid state. The S stands for solid. The G shows that this chemical species or reactant is in gaseous state. We talked of other states as L, standing for a chemical species in liquid form, and AQ, standing for a chemical species in solution state or aqueous state. Let me think I've cleared that part. So that was part C. Only if you have any query about it. Part D, part D is like mention any other uses of carbon monoxide in daily life. The other uses of carbon monoxide in daily life. We have a number of them. We have very many. We cannot finish them. The carbon monoxide is used as a preservative. That extends the lifespan of food. They use it as a preservative. The carbon monoxide is a raw material for manufacture of many organic chemicals, such as formic acid, methanoic acid, methanol. This is a it is a derivative. This one, when manufacturing several pharmaceutical products such as hormones and enzymes, carbon monoxide is a derivative. It is one of the species from which these hormones and enzymes, the artificial hormones and enzymes, are manufactured. When we talk of hormones, we know they can make insulin in hospitals and so many others. The carbon monoxide is used as a shielding gas in welding for those who will have some physics further than that level. You'll find of carbon gases used as shielding gases in welding, metal shielding gases, and gaseous shielding gases in welding. So the carbon monoxide has a number of uses we cannot finish, and I know you can build from these two. Yeah, they have many. Yes, carbon monoxide does not support life. It's such a gift. Carbon monoxide does not support life, and since it does not support life, no bacteria or fungi will survive. Remember, in presence of carbon monoxide, the oxygen takes no part. It is always reduced, or the air is reduced from carbon monoxide, which does not support life. It is not used in extinguishing fire. Carbon monoxide does not only support life, but I don't know about its fire extinguishing properties. I will not lie. Yes, I've talked about it as a raw material for manufacturing of many organic chemicals. It is also a raw material for the manufacture of fertilizers, such as urea. Urea fertilizers can be manufactured from carbon monoxide. So we have various uses of carbon monoxide. We cannot finish them. And if you don't mind, if you don't have any big question, you can let me stop there and meet in the next question shortly. We're uploading that question in the group. We are coming back right now for another question. I'm grateful for the contributions. Timothy is with us. Timothy has finally appeared. The one you can, the one Baruch is, why isn't there an hypothesis? You can put it. No problem with it. But I wanted to spare space. You can put an hypothesis. And the hypothesis for this, to me, I could say metals conduct it better than non-metallic elements. That could be my hypothesis for my experience. So let me think I've answered you, Baruch. Kasoma was contributing. It is used as a preservative. Yes, Kasoma. Preservative of what? Timothy, I think carbon monoxide can be used as a reducing agent in the production of iron. Yes, not production, let's be clear, in the purification of iron ores.